What's up, guys? Chad here with the Reptile Rangers. Now we're at the Kernersville Reptile Zoo and Medical Center again today, and we're going to talk about genetics. Just introduction to genetics, okay? Now, before we get into that, right here in this corner is our subscriber button, okay? Make sure to hit that subscribe button, hit that like button, hit the bell for notification. We appreciate you following along week after week, okay? Now, let's talk about simplified genetics. Now, we're not going to get all wordy into the things like proteins and enzymes and genetic markers, alleles, and all this other stuff that goes into it. Yes, that stuff is important if you're involved in the science part of it and you want to learn about the scientific part of it. Then that stuff is important to learn about. But this is not one of those in-depth kind of videos where we're getting so sciencey that essentially if you're not into it, it becomes boring. We're just teaching in this video, we're just talking about the simplified ways of understanding genetics, okay? More primarily like recessive, dominant, and codominant genes, which you're going to find in pretty much everything when it comes to your color morphs or your patterns, okay? Now, the first thing we're going to show, and I'll show different pictures, you'll see different pictures popping up here, is we're talking about, let's go over the three key traits, genetic traits that you're going to have when it comes to different patterns and different colors, which is going to be recessive, dominant, and codominant, okay? Recessive, the simplified version of recessive means it takes two to tango, okay? So, for example, recessive means, let's say for an albino, if you want to produce an albino or a piebald, or in the ball pythons, let's say clown, or in Burmese pythons, everything other than the hypo is a recessive genetic. The granite, the green, the labyrinth, the albino, so on and so forth. If you want to produce the albino, so we're going to go back to the albino specifically, you have to have both parents carrying the alleles or the genetic markers to throw the albino, okay? Now, in the case of when you hear the term het, okay, H-E-T, het, it's het for something. That means that the parent or one of those animals carries the marker to throw that color, whether albino, piebald, whatever. So let's say, for example, we take and we pair a normal het for albino to another normal het for albino. At least a portion of that clutch is going to come out albino. You're going to have a portion of that clutch come out normal looking and still het for albino. When you have two what we call visual markers, so a true albino like this and a true albino paired to it will produce an all albino clutch. The difference is, like in the case of your dom-codom genetics, okay, for example, your dominant genetics would be spider, okay? Dominant genetics would be pinstripe. So let's use those two for an example. Spider or pinstripe. If you pair a spider to another spider, it's just going to produce spiders, okay? The great thing about codom and dominant genetics is it does not take two to tango, essentially. It does not take both the male and the female carrying those genes to throw the spider genetic. It only takes one parent, okay? Now, the difference between a dominant and codominant gene is codominant means that you can create a super form, okay? Now, in the case of albinos, it takes albino to albino, or at least a het albino to an albino, or het to a het, to produce the actual albino gene. In a codominant situation, okay, in a codom situation, you could take something like a Mojave and pair it to a lesser, and it creates a different form, which is the blue-eyed leucistic, like this right here, okay? So, again, understanding the simple parts of the genetics is a great starting point to your breeding program. Understanding which ones are recessive, because if it's recessive, then you're going to have both male and female carrying the markers one way or another. Either it's visually that color that you want it to be, or it's het for the color that you want it to be. Because if you pair an albino to a normal that is not het for the albino, you're going to produce nothing but a clutch of normal het albinos, okay? Now, we could get into the percentages, 25%, 66, 75, 50, whatever, but I'm not going to get that deep into that again. That's just not really that important for this specific video. It's just, if you pair one to the other, this is what's going to happen, okay? When you pair a dominant genetic to a normal, you're going to get half normal, you're going to get a portion, or let's say a portion normal, and a portion of that dominant genetic like the pinstripe or the spider. The thing is, when you pair a pinstripe to itself or a spider to itself, it's not going to create anything different other than a pinstripe or a spider. When you take a codominant gene, anything that's codominant, and there's tons of them, pastels and Mojaves and lessers, and oh man, the list goes on and on and on and on and on and on and on. Butters and vanillas and yellow bellies and inchies, and just, again, the list goes on and on. Any of these codominant genes, when you take and you pair that either to another one, like itself creates a super form of itself, so that would be the codominant gene. So you take anything that can pair off to one another, and it creates something even different than what those two are. That's a codominant gene, okay? Now, again, I hope this has been helpful. I hope this has been at least somewhat helpful for you, especially in getting started in boas or Burmese or corn snakes or ball pythons, or anything that has an excessive amount, carpet pythons, or even another one. Anything that has an excessive amount of different variations in colors and patterns, understanding what the difference is and how to work with the genetics that you got, or how to find the genetics that you're looking for and what it's going to take to make those genes, okay? Now again, this has been Genetics, Introduction to Genetics, or Genetics made simple just as a beginning factor. We appreciate you following along. Again, this is Chad with the Reptile Rangers. We are here at the Kernersville Reptile Zoo and Medical Center. We appreciate you following along week after week after week. Make sure to hit that subscribe button, hit the like button, hit the bell for the notifications. Our information will be in the description below. Feel free to make comments. Feel free to write us in. People are writing us, asking us questions all the time, or wanting us to do different videos on different topics. So we appreciate you again following along week after week. We'll either see you here at the zoo, or we'll see you on the next episode. Later.